All right, today we're going to be going over Unit B, Lesson 7, and this is linear equations in all forms. So let's start with the table. We haven't really seen this yet, but, ooh, that's super big. Psych. Let's make it smaller. So for our tables, they look like this. Okay, so we're given our x-coordinate and our y-coordinate, and when they're right across from each other, that creates our points. Okay, so a table is a list of ordered pairs it just lists it in X and Y form, okay, which can be helpful. All right, so that's our table. We'll see an example of it later in this lesson. Our slope, as we know, what variable always shows slope? RM, of course. On a graph, we see our slope, which we already know, from 2 points. When we get our slope from 2 points, remember, we first have to label them y1 and y2. Sorry, not y1 and y2. x1, y1, x2, y2. Okay? From there, we know that we take our y2 minus y1 and put it over x2 minus x1. Okay? Now, this makes sense why we put our y's on top, because our rise is very close to our y's. Right? So when we rise, we go up the y axis. When we run, we go up the x. Okay? So remember, that's why we have to use our y's on top, x's on bottom. A lot of people struggle with this. All right. So we have our slope, and obviously we know that's our m. Now, on our graph, we've gone over this, but just in case you need a reminder, on a graph we have our y-axis, which is super important for our y-intercept. So remember, our y-intercept is where our line crosses this axis at a certain point. So that's how we always get that point. But don't forget, we also have our x-axis. And our x-axis, when we're plotting points, remember, we always plot our x's first and then our y's. Okay? X's and then y's. So we have to go over before we go up. Cool. All right, our slope-intercept form. Okay, don't forget slope-intercept just because we started something else. We have y equals mx plus b. Now, we always know that our m is our slope. Okay, so let's write ourselves a reminder. Slope. And our b is that, ooh, not what I wanted, is that y-intercept where our line crosses the y-axis. Okay, that's why it's called a y-intercept. because it's where our line crosses the y-axis. Okay? Moving on. We have our point-slope form. Okay? Let's go back to our slope-intercept form really quick. Remember, our intercept comes from our b, and our slope comes from our m. Those are the two variables we have. Those are the two things we really care about in slope-intercept form. Now our point-slope form comes from one point and still our slope. Okay? Remember, these are just two ways of writing the same information, because we can turn our point-slope form into our y-intercept form if we need to. So for our point-slope form, like we went over yesterday, we have our y minus y1. Remember, this y doesn't change. We never substitute. This y, our y1 and our x1 come from our point. Okay, so then we have our m, which is our slope, x minus x1. So again, this x, we never substitute either. Only our y1 and our x1. Okay, that's what comes from our point. Only these two. Now, the weird thing about point-slope form is because we have this subtraction symbol, right? This one and this one. Every time we see a negative number for our x1 or our y1, we know that the point is positive, okay? We know that the y or the x coordinate in the point is positive. Now, if we ever see this as plus, so if plus x1 or plus y1, then our number is going to be negative in our coordinate. So I'm going to say negative coordinates. Okay? And remember, our coordinates come from our points. All right. Point slope. Now, when we see a word problem, in a word problem, a variable is always going to represent missing amounts. So anytime you see a variable, that's something we're going to be focusing on because that's missing. Now, our starting amount so let's say I start with $5. That starting amount of $5, that's our y-intercept. Okay, so our starting point is always going to be that y-intercept in our equation, or our b. All right, now if you ever see the word per, so if we say something per something, this shows that we're going to have a coefficient, which remember, a coefficient is our number connected to our variable, our coefficient with a variable. Okay, so no longer is it just going to be x or just going to be y. This is going to have a coefficient with it, or a number with it. All right. Now, we have another nickname for these equations that tell us these same things. This is called standard form. So when we write something in standard form, it's going to look like ax plus by equals c. Okay, so our coefficient connected to our x is always a positive whole number. Our b, it doesn't matter if it's positive, so it can be positive or negative. Whole number. Okay. So no fractions for a or b. These two are both whole numbers, and our a has to be positive. Okay? But our b can be positive or negative. All right? In our c, same thing. It's going to be positive or negative whole number. But our c is a little bit different because if you can notice, there's no variable on c. Okay? So we want a constant for c. So we solve our equation. Again, it's going to be just like our slope-intercept and our point-slope form. It tells us the same thing, but now we're going to rearrange for there to be a positive whole number on x and positive or negative whole numbers for b and c. We're just moving it around. Just like point-slope and slope-intercept forms, both of them, all we did was rearrange. Okay? So we can always solve for all three, no matter what we have. All right. So let's see some examples. For our problem 1, we're going to be given the table first. So our table is, again, we have our x and our y's. And we have 4, 5, 8, 8, and 20, 17. Okay? Remember, the one right across from it goes with it. So this point, we know is 4, 5. This point, we know is 8, 8. This point turns into 20, 17. Okay, this is how we read our table. So, if we look for slope, right, our slope's important. We always need a point, which this table gave us 3. And we need a slope for anything that we do. So our slope, we got to pull 2 points from our table. I'm going to choose to pull 4, 5 and 20, 17. Again, I could have pulled 8, 8, but I'm just choosing these 2 points. Now I have to label. One of them has to be x1, y1. One has to be x2, y2. So I'm going to choose this first point to be my x1, y1. And this second point I'm going to choose to be my x2, y2. Okay, now that I've chosen this, we know that our slope formula is y2 x2 minus we know it's y2 minus y1 over x2 minus x1. So now we have to substitute and solve. So when we substitute, we get 17 minus 5 over 20 minus 4. Okay, now we just have to simplify. 17 minus 5 is 12. 20 minus 4 is 16. Okay, now we need to simplify this fraction. So we have to say, okay, what can we divide both of these by and still get a whole number? I notice that I can divide it by 4. Each of them. When I divide by 4, I get 3 over 4. Okay, and this is my slope. All right, so now I have a point and a slope. None of my points are my x-intercept or are my y-intercept. So I'm going to start with point-slope form. For my point-slope form, I have to pick one point. And I'm just going to go ahead and stick with 4, 5. And my slope, which is 3/4. These are the only two things I need for point-slope form. So let me just label this x and y just in case I get confused. Now let's put it in point-slope form. We know our point-slope form is y minus y1. We know our y1 comes from our point. So my y of my point is 5. Notice, since the 5 is positive, I didn't change my negative or my minus to a plus. Equals our slope times x minus our x coordinate, which is 4. Okay, this is all I have to do for point slope form. So this is my answer. Okay, now that I know point slope form, this is a really easy conversion to get my slope intercept form. So from point slope form, I'm going to go straight to slope intercept form. So for my slope intercept form, I'm just going to solve my point slope form for y. So I have y minus 5 equals 3/4 x minus 4. Now, first thing we need to do is simplify both sides. So I need to do the distributive property. Nothing changes on my left side, so I'm going to keep it the same. Now, 3/4 times x gives me 3/4 x. 3/4 times 4, let's just do it in the corner here. Remember, if it's a whole number, we can put it over 1. We get 12 over 4, because we multiply straight across. Twelve divided by 4 is 3. So then I get minus 3. Now we just have to solve. So how do we get y by itself? We have to get rid of this negative 5. The opposite of subtracting is adding. So we're going to add 5 to both sides. Negative 5 plus 5 equals 0, so we can cancel it. All we have left is y. 3/4 x is not a like term with 5, so that stays the same. Negative 3 plus 5 equals positive 2. Okay, so now that I solve for y, I have my slope-intercept form. Okay, because I have y equals mx plus b. Our m is our 3/4, which leaves our b as 2. Okay, so now we have our slope-intercept form. Okay, from our slope-intercept form, it's really easy to write our word problem. Okay, so we have to come up with something that has a start of 2, right? And then we have to incorporate our slope. So our word problem for this could be, we have a zoo, okay? And this zoo has 2 dolphins to start. Okay, so again, remember our starting point. Our starting point has to be our b, which we know is positive 2. So that comes from our b. And now we need to incorporate our slope. So we're going to say the zoo gets 3 dolphins. Every 4 years. Okay, so since we know our y-intercept is 2, our y, which is our rise, so the 3 from our slope, has to be referring to the same thing. So in this case, dolphins. Okay, so our y's refer to dolphins. And then we needed another variable, which we picked years. Okay, so our x is years, our y is dolphins. And we know that because our y-intercept was 2 dolphins. Okay, now let's go ahead and get standard form out of the way. This also comes from our slope-intercept form. Remember, our standard form is ax plus by equals c. Okay, so now what we're going to do is we have our slope-intercept form, y equals 3/4 x plus 2. But now it looks like we have to get our x's and our y's on the same side. So I have to pull over my x first. Now if I want to move this whole term, I'm going to subtract the entire term. So minus 3/4 x. What I do to one side, I have to do to the other. So now on this side, I have, since they're not like terms, I can't put them together. So y minus 3/4 x equals, these two cancel, 2. Okay, all I have left is 2. Now, x's should be first, right? So I'm going to rewrite it as negative 3/4 x plus y equals 2. But what are my stipulations with a? I have to have a positive whole number for a. So, in order to make it positive, I'm going to multiply everything by a negative for sure. And then to get rid of the fraction, I'm going to multiply by the denominator. Okay, so I'm going to multiply everything by negative 4. When I do this, these cancel, right? And our negatives cancel. So for my x's, I get 3x. For my y's, 1y times negative 4 equals minus 4y. And 2 times negative 4 gives me negative 8. Okay, so this is my standard form. Remember, we multiply by the denominator if we have a fraction. All right, now finally, let's go up and graph what we've just made. Okay, so that's step number 7. Again, let's point out our x-axis, because that's really where we want to start, right? From here, we can use our point slope form. And we know that our first point is going to be at 2 because that's our B. So that's our first point. Now if we look at our slope, we know it's rise over run. Again, if you want to see the hint again, I can gladly do that. But we're going to do rise 3. 1, 2, 3. And run 4. So 1, 2, 3, 4. So our next point must be here. Last step, we just have to connect our points. And that makes our line. All right. Now we finished all of problem 1. And it all started just from a table. Okay? So we knew all that just from one of these pieces. All right, let's try another one. But we're going to start somewhere else this time. So problem 2. This time, let's try starting with our word problem. So if we're given this word problem, you have $16. Pop costs $4 per bottle. Chips cost $2 per bag. What a steal. Okay? Chips cost $2 per bag. Now, how many pops and chips can you buy? Okay. Normally this would have a direct answer, right? But since we have a lot of different combinations we could use, now this is all of a sudden a line instead of just, oh, you could buy this many bottles of pop and this many bags of chips, right? Because since there are so many options, now it's going to be an equation rather than just a point. Okay, so from here, let's talk about our standard form. From our standard form, we just have to assign variables, okay? So our x, we're going to make that our pop. And remember, that's $2. Our y, then, is going to have to be our chips. And you know what? I messed up. If we go back to our word problem, our pops cost $4. And our chips cost $2 each. Okay? So, we know that however many pops we buy, it's going to be $4 per pop. So, since it's $4 per pop, we know we're going to have the coefficient of 4 times the amount of pops that we get. So 4x plus however many chips we get, which is $2 per bag. And the total amount we have to spend is 16. Okay? This is our standard form for our word problem that we just got. Now, real easy, from our standard form, we can go all the way up to our slope-intercept form. So our slope-intercept form is, remember, y equals mx plus b. So we need to get y by itself. So let's take our equation we already had. 4x plus 2y equals 16. Let's solve this for y. So first we have to move the entire term with our x over to the other side. The opposite of positive 4x is negative 4x. What we do to one side, we have to do the other. 4x minus 4x equals 0, so we cancel, leaving us with only 2y left on that side. Now, 16 minus 4x, are these like terms? No. These are not like terms because they don't have the same variable. So we can't put them together. We have to list them. So 16 minus 4x. Now, we want y all by itself. We don't want a coefficient. So we have to do the opposite of multiplying, which is dividing by 2. What we do to one side, remember, we have to do to every single term. So 2 divided by 2 is 1. We don't have to write the 1, so y equals 16 divided by 2 is 8. Minus 4x, or negative 4x divided by 2 is negative 2x. Now, this could be our answer. But if we really want to write it in y equals mx plus b form, we have to switch these two around. Okay? So y equals negative 2x plus 8. And now we know we have our slope, right? Because that's our m. And our y-intercept, which is 8. Okay? So from here, we know our slope, right? We were given our slope when we solved. We know our m equals -2. But since we want it in fraction form, we're going to say -2 over 1. And since this is negative, okay, since this is negative, we know we're going to go down 2 because our rise is negative. So down 2 and still over 1. Good. Okay. Now let's write our table. We also get this from our slope-intercept. So our table, again, we have x, y. We know one point from our b. Remember the point we can write from our y-intercept? We know our x is 0. And our y is our b. So 8. Okay. We know this because of our b. We don't have to find that point. To find our other points, we're going to use our y-intercept, or our slope-intercept, form. And we know that our y is going to equal, whenever we plug anything into x, -2 times whatever we plug in, plus 8. So this is where we need to substitute. We can substitute any number, but since we know we're going to have to graph, let's pick an x that's on our graph. So I'm going to pick 1 to make it easy. Okay. So if I pick 1, we have y equals, okay, if I pick 1 for my x, I put it in my x column, and now we have to find out what y equals. So y equals -2 times 1, which is -2, plus 8. -2 plus 8 equals 6. So I know one of my points is 1, 6. Okay, let's find one more point. If I plug in I'm going to rewrite this. Y equals -2 times whatever we plug in for x, plus 8. Okay, all we're doing is substituting. Now I'm going to plug in -3. So if I plug in a -3, I get y equals -2 times -3, which is +6, right? Negative times a negative is positive, plus 8. 6 plus 8 is 14. So that's going to be my y. So I plugged in -3, so that's my x. And I got out 14, so that's my y. Okay. So I filled in a couple points. Now, let's go to point-slope form. For my point-slope form, all I need is one point and a slope. So I'm going to pick one of my points that I just did, and I'm going to pick 1, 6. Remember, this is my x, this is my y. It's also shown on the table, x and y. So I'm going to pick 1, 6, and I already knew that my slope is -2, 1. -2 over 1, right? Okay, so let's write our point-slope equation. We have y minus y1, which is 6. Again, since it's positive, this stays minus. Equals our m, which is negative 2. Or we could put negative 2 over 1. Either way. Times x minus our x from our point, which is 1. Okay? Since 1 is positive, again, this is going to stay a minus. If it was negative, it'd have to switch to plus. Okay? So this is my point-slope form. And lastly, let's graph. All right, when we graph, again, we have our y-axis. And let's use our point-slope form. Or our slope-intercept form, right? Most people are most comfortable with slope-intercept. So let's start with, positive 8. Shoot, that's not on the graph. So, instead, let's start with one of our points we found on our table. 1, 6. So again, over 1, up 6. And we know our slope, we go down 2 and over 1, because it's rise over run. So I'm going to go down 2, over 1, and that's going to be my new point. Now all that's left